Climatic classification of Köppen, ideally you have to understand basically that what is required to be read there. So do you need to learn the various codes? Not very important. So what do you need to understand? That the codes represent which kind of climate and which parts of the world experience that climate. So if you understand the basic factors which can cause rainfall, dry conditions in a region, that is the shifting of the pressure belts, and due to the shift of the pressure belt, sometimes in certain areas the winds become onshore, in certain areas the winds become offshore. That is more than sufficient. If you are comfortable with those basics, very, very comfortable, then climatic classification will be easily understood. Okay. Agriculture is a part of geography. So can I take agriculture as an, because currently I'm doing MSc of horticulture. Take a look at the syllabus. Take a look at the syllabus which is present in the notification, and accordingly make your decision. Uh, Dwapayan, when we talk about building of embankments, so that is where across the sides of the rivers you build a kind of a brick wall like structure which can contain excessive amount of water and not allow it to overflow. Sakshi, Saturday we are going to have an extra session from around 6:30 to roughly around 10. If required, we will extend it for some time, but around that time. Just a moment, guys. Aspect of desertification of the soil. Those are the factors that are relevant for the examination. So here you have to understand what is it that is going to be asked for the prelims, what is it that is going to be asked for the mains here. So when we talk about the prelims examination, here you have portions, suppose with soil types, areas, where they are found, basic properties, okay, and also along with that, basics of soil erosion and soil conservation. Okay, so that is a portion from which questions are oftentimes asked in the prelims examination. When we talk about the mains, in the mains examination, subjective questions are also asked from this area, and that is about the issues pertaining to soil, that is erosion, degradation, and how to conserve soil. Formation of soil, factors associated with the formation of soil. Formation of soil. Okay. So these are the various different areas from where questions are frequently asked. Now, generally, UPSC is no longer restricted to asking questions which are very factual in nature when it comes to particularly the mains examination. So, in the mains examination, you need to have a broader view. You need to have a broader insight about why a particular region is experiencing an issue, or what are the various factors which are leading to soil degradation, how soil degradation can lead to desertification in the prolonged way. So that those are the factors that one has to concentrate upon. So here, one by one, we shall be taking a look at each of these relevant areas. But here also, in the case of forest, remember I had asked you that please read the forest after you have read the portion of Indian climate. Here, I would request you to read this particular portion of soil after you have read the physiography. Okay, please do it after the portion of physiography. After the portion of physiography is completed, after then, because once you understand the portion of physiography as we have done for the origin of the various different rock systems, the existence of the different types of terrain, and topographical features in different parts of the country, automatically you gain an idea about which kind of soil can be found in a certain area. But when we talk about soil in itself, what do we understand by soil? What is the meaning of, or how is it that the soil is created? So soil basically is created by the degradation and the weathering, and many of the times the deposits of various materials as well. But it is the degradation and the weathering of the rocks which ends up forming soil in any particular area. So the formation of soil in itself is dependent on many different factors. But this process of formation, that is a very slow process. It is not a fast process. The process of formation of soil in itself, sometimes it takes millions of years to form a thin layer of topsoil. And that topsoil, once it gets eroded, it is almost impossible to recharge that topsoil in a shorter period or a shorter duration of time. Okay, so here let us take a look at them. So basically, when we talk about the soil, it is a mixture of rock debris and organic materials which develop on the earth's surface. It takes millions of years to form soil up to a few centimeter in depth. So rock debris, organic material which get decomposed in the soil, all of them, they form a part of the entire structure of soil in itself. Now here, if you take a look at it, so whatever is the rock debris that we are talking about, how has this been attained? So this has been attained either by weathering of the rocks, either by weathering of rocks, or deposition of materials. Deposition of eroded materials. Any of these processes can lead to the formation of soil as such. So here you will observe that it is a kind of a renewable natural resource. So in the sense that it keeps on getting produced. So the process, if I can make you familiar with that. So here, let's suppose in a region you have the presence of rock systems. Let's suppose a lot of rock systems. So initially what will happen, that these rocks, they will start to disintegrate. These rocks will start to break. Okay. Now, here, initially they break into many of the larger chunks. They won't break into many smaller parts. They will be breaking into the larger chunks, for suppose. As a result of weathering, of course. Okay. Now, when they break into these larger chunks, they will then be broken further again, maybe again in hundreds of years and so further. So they will again be broken here. Okay. And this continues, this process continues. So at the end of the entire process, which can span for hundreds or thousands and even millions of years, you come across a situation where at the bottom you will still observe, this is the soil horizon and the profile. So unweathered, unweathered parent or base rock, or base rock. Then above that you will have very large pieces. Okay, you will observe a kind of the existence of very large pieces. So partially fragmented large rocks. Large rocks, which is also a part of the fragmented base rocks in itself. This is nothing but the broken form of base rocks. Then further higher up, you have the larger subparticles of soil, larger pieces and particles of soil that is to be found here. Okay. So you will have larger particles of fragments, soil particles, which is also the subsoil as it is referred to. And this is your finest portion or the smallest particle. That is what we consider as the topsoil. It consists of various minerals plus organic materials or humus materials or humus. This fragmented, or rather than large rocks, let me write here parent rocks. Okay, so that is the how the entire soil profile appears to look like, appears to look like, to be arranged in various different horizons, and that is a feature that you will find. So it is a kind of a renewable natural resource and also a kind of a living system out there. Okay, now we come to the various different factors which can influence the formation of the soil. Now before that, you would have heard about the term fertile soil, or the soil is not very fertile, infertile. At another place, the soil is very fertile. At XYZ place, the soil is infertile. So that soil fertility, when we talk about the fertility of the soil, so what is that soil fertility? When is it that we say a soil is fertile? So what do you think? When do we say that the soil is fertile? Humus, amount of mineral present. So if in a particular soil, let's suppose you have lot of cadmium and uranium, will that be considered to be a fertile soil? Good, Sakshi. So basically, the soil is rendered to be fertile or referred to as fertile when it can support the growth of vegetation. It can support the organic matter into it. So that is when the soil is considered to be fertile. Now, how does that ability to support those vegetation and those organic matter come into existence? So the soil should be rich in nitrogen, phosphate, potash. These are the macronutrients. Other than that, the soil should have fine particles. Or even if it doesn't have the fine particles, it should have the ability to trap air amongst itself and retain moisture within itself. So that capacity to retain air and moisture within itself, that is what is referred to as the soil fertility. So here, when we talk about fertility of soil, so ability to hold various air and moisture amongst itself. This is an important factor of fertility. So this comes when the particles of soil are small and fine. That is the requirement. Other than this, it needs to have certain macronutrients such as which are very important for the growth of the plants in general. So availability of nutrients such as nitrogen, phosphorus or phosphate, and potash, along with availability of organic matter. Okay. So these are your basic requirements for a soil to be turning fertile. Now, nitrogen, generally across the world, you will find this as a common factor that across the world, all the soils, they are very poor in terms of the nitrogen content. And we have discussed about the reason for that. Why do you think that across the entirety of the world, majority of the soil types, they are poor in nitrogen content? What do you think? Good, Manikandan. Very good. Because nitrogen doesn't react very readily with the rocks. And that nitrogen, its inability to react readily, it is in inert state and it doesn't react readily with the rocks. So the rocks won't have many of the nitrates getting created. And when the rocks don't have many nitrates getting created, then obviously the final product that is not going to have the soil particles in, or the final product that is the soil particles, they will also be poor in nitrogen. That is why one of the most prevalent fertilizer which is used to augment the soil fertility is that of nitrogen fertility augmentation, and that is done with application of urea. So that is why urea is so significantly used. Now, urea is something which is manufactured in many of the cases with the help of the natural gas, as well as wherever you have fossil fuel. So you have fossil fuel based production of urea. India doesn't have a lot of capacity of fossil fuel, and fossil fuel generation is limited in India. So we are still very much dependent on the import of urea from abroad. So that is why it brings us a rising import bill for us as well. But we do provide nitrogen at a very subsidized rate, due to which you will find that the people end up, or the farming community in general, they end up applying nitrogen in, or urea in, overt quantities, right? It is available in a very cheaper or subsidized rate, and it is one of the fertilizers which is readily available. So people end up spraying it up, utilizing it up as max, to the extent as possible. Now that has also led to soil degradation. If you over apply the fertilizers, and understand this concept, if you over apply the fertilizers in the soil turns out to be infertile. Now here the common logic might play out in the sense that, okay, but the soil will require fertilizer. So if I am applying, rather than 1 kg, if I am applying 100 kg, how will the soil go bad? The soil should become much better. So that is not how it goes. If, let's suppose, every day, to give you a kind of an analogy, let's suppose if every day you require around 2 chapatis for consumption. Now, chapatis, or the food that you have, that is required for your self-sustenance. So if someday someone, what they do is they shove over 400 chapatis inside you. Now, will you then be perfectly okay for 400 days or 200 days without requiring food anymore? No, you might die immediately. So that is the same case with the application or over application of fertilizers as well. When you over apply the fertilizers, all the macronutrients of the soil, they end up getting distorted, and you have various different organic matter, the microorganisms, etc. Now they start dying immediately. And that is when the soil starts becoming unproductive. So that is why excessive application of fertilizers is one of the chief causes for the soil turning out to be infertile. Okay. Now, here, when we talk about the process of formation, or the factors affecting the formation of the soil, so you have various different factors which will influence the soil formation and the soil property. Now, one of the important factors which will influence the soil property is the parent rock or the bedrock. What are the parent rocks or the bedrocks composed of? It is, after all, that degradation and weathering of that parent rock which will give rise to the soil. So what is it composed of? So here, provides or is responsible for the mineral balance in soil. Okay. So it is responsible for the mineral balance and the mineral presence that you have in the soil. Is also responsible for the basic properties of the soil. Determines the basic properties of soil. Okay. So here, when we talk about the examples of it, take the case of the Deccan traps. Now, Deccan traps, they consist of the flood basalt, the basaltic lava, which in a way spreads over a large area like a flood. So the Deccan traps is composed of flood basalt. Now that flood basalt, when it gets disintegrated or weathered, then what do you have? You have the presence of black soil. So here, weathering of flood basalt gives rise to black soil. Okay. So that is what gives rise to black soil. Another example, weathering of igneous and metamorphic rocks impregnated with iron leads to which kind of soil? Very good. Red and yellow soil. Okay. So forms red and yellow soil. So that is how you have. So where do we find these igneous and metamorphic rocks in our country? Across the Chota Nagpur Plateau, across the Bastar Plateau, across the region of the Karnataka Plateau, across the areas and the stretches of the Bundelkhand Plateau, and so all these areas you will find the red and yellow soil. Then, when we talk about the climate here, so climate in the sense, climate is also responsible for influencing the formation of the soil. When you have a rapidly changing climate, that is, you have, let's suppose, a condition of a tropical climate. Now in tropics you have the conditions in certain areas, rainfall as well. Now the temperature goes to the extremities, so there the degradation happens very quickly. Okay, so here the degradation happens very quickly. So in extremities, very high temperature and very high rains, availability of rains, you have formation process becomes quicker. Okay, so why? Because the process of weathering is accelerated in that case. So process of weathering is accelerated. Then if in a region you have the presence of lot of vegetation and other forms of soil, it will also add on the organic matter into the soil. So it will enrich the content of organic matter. So this increases the availability of increases the availability of organic matter in soil. Okay, and when you have increased amount of organic matter, the microorganism, the earthworms, etc., their count will grow up and the soil fertility also grows up. Now when we talk about time, so for example time, so how is it that time is a factor? So greater the time taken for the process of formation of the soil, finer will be the particles of the soil. Lesser the time taken for the formation of the soil, you will have larger particles of the soil which is available. So here, greater the time taken, finer is the particle. Finer is the particle means greater retention of air and moisture, something that we have seen here. So finer the particles, greater availability of air and moisture. So here, greater the time taken, greater or extent of weathering happens, and that means availability of finer particles. You will observe a greater availability of finer particles. Then actions of running water, wind, and glacier. So these actions, they will also end up eroding a particular area consisted of rocks. So whatever is eroded will eventually get deposited. So they carry out deposits of very fine particles. In the case of running water, you have the deposition of silt. In the case of glaciers, you have the deposition of till. Now these are very fine particles and also very rich in minerals because they are taken directly from the rock portions and the rock surface. So yeah, you will observe increases the amount of deposits, okay, and these are fertile deposits, okay. The fertile deposits will be observed to be created. uh, in which time class will be held on Saturday? So the extra session for Saturday will be held from around 6:30 in the morning, and we will have that. And we are, as I had also told you for the previous couple of classes, that we are arranging a doubt clearing session, a separate session only for the doubts that you have in the entirety of the subject of geography that we have covered. So do accumulate your doubts. We will send you a request for submission of those doubts as well. So you submit those doubts, and then in the doubt clearing session we will be addressing any kind of doubts that we have. Now, by any kind of doubts, I don't mean the doubt pertaining to Chandrayaan 3. I mean the doubts associated with the portion of geography, any portion of geography, any kind of doubts that you have. You would have read almost all the portions would have been covered by now. So do accumulate those doubts, and we will send it over to you with the details of when that session will be held, and you send over those doubts to us, and those will be addressed. Okay, 6:30 in the morning. Yes, is the extra session. That is not the doubt clearing session. Doubt clearing session is different. Tomorrow there is a class. Absolutely, yes. Okay, tomorrow there is a class. This Saturday, early morning, we will have an extra session. Okay, 7:30 a.m. would be better. Why not then 10:30 a.m.? 10:30 a.m. would also be better. So please understand there are various different issues at hand. So many of the candidates, they need to carry out further activities after that. So that is why. So we'll have 6:30, okay, the extra session from 6:30 a.m. on Saturday. Now, then the activity of the decomposers that you have, that is you have the various different types of decomposers, and decomposition process also, when you study in the portion of your environment and ecology, decomposition process in itself is comprised of various different stages. It is comprised of 5 different sets of stages. So you have fragmentation, then you have leaching, then you have catabolism, then you have humification, then you have mineralization. It is carried out by variety of species out there. So these decomposers also enhance the presence of organic matter. Here, rather than enhance, you can have a better term, that is influence. Okay. Now, then, other than this, you also have a variety of chemical and organic changes which take place in a particular area, which will alter the soil property, which will alter the rate of degradation in certain areas. So that is also altered, and all these various different processes, they end up forming the or end up influencing the formation of soil as such. Okay. Now, then here is the layers of the soil, what is also referred to as the soil profile. So when we talk about the layers of the soil, so you have to understand that the soil in itself is formed as a result of the degradation and the weathering of the base rock or the parent rock. So you will observe the unweathered parent rock at the base, then weathered parent rock material, subsoil which you have larger particles, very poor ability to retain soil and moisture, because when you have larger particles of the soil, then any amount of water that you put in, all that water will start seeping into the lower reaches. So that is why the retention is not there. And then the top soil, it is the most fertile one, most fertile portion. Okay. Not understood the decomposer part. Decomposers, they are required or in order to carry out the decomposition of any organic matter. If you don't have the decomposers are what? Microorganisms. So these microorganisms, they allow for the decomposition, the degradation, and the breakdown of the organic matter in the soil, and they will return those as nutrients into the soil. So that is where you have the presence of the organic minerals, the organic material that you talk about in the soil. That is some product of the process of decomposition in itself. Okay. So that is the aspect or the role. Now we come to the various different classification of the soil, various different types of soil. I see a lot of issues with regards to recording. Please, as of now, concentrate on the session. Otherwise, this session also, you will have the same complaint. Roots will also help in breaking the rocks, Yuvraj. Yes. So, what is the issue that you have with the regards of recordings? See, please understand the recordings have a kind of a time limit. Beyond the time limit, the recordings will be removed. Okay. And that is a kind of a. So, if any portion which is left, try to attend it in the next session, whenever the next module or the next session is held. And that will be your aspect of the various different session. Any portion which gets left over, you can attend another session or another batch of it. That facility you will have. Okay. Annotations of the PPT will always be available, has always been available, and will always be available. Recorded lectures you will have. The recorded tablet lectures you will have. Don't worry about that. It is the live sessions and their recording that will have a time limit. Okay. Right. Okay. Now we come back. So ideally, always advisable to pay attention in the session when the session is going on. I think once you complete a particular session, that is more than sufficient for your overall understanding, right? And then you can switch over to the portion of the tablet as well. Tablet lectures are anyways there. That is the recording portion which is anyways available to you. Understand that. So you have the availability of the tablet lectures, you have the live sessions as well. So you can always augment that for your preparation. Okay. Now, okay, how many of us have not understood that the portion of decomposers? It is very simple, guys. Have do we know the meaning of decomposition? What is decomposition? Do we know the meaning? What is decomposition? No? Okay. The breakdown of the organic matter, that is referred to as decomposition. So when we say organic matter, here if you have a soil, here you have, let's suppose, a plant. Now the leaves will fall, let's suppose. The leaves fall from here. Now on the ground you have these leaves. On the ground you have these leaves. Intact, lying intact. Now will we consider the soil to be fertile? If the leaves are intact as they are, will we consider the soil to be fertile? Absolutely not. That means it doesn't have any kind of mineral presence, organic mineral presence. So this leaf will be broken down by various different objects, by worms, by insects. They will break it down. They will then carry out the process of decomposition. So the process of decomposition is important, which brings about the availability of organic matter in the soil. Any portion which is not understood in this? Plant was there, so it was already fertile? Not necessarily. Not necessary that where plant is there, the soil is fertile. No, it is not at all given. It might be very infertile soil, and only one kind of plant might be growing in that area. Is that understood now? Okay. So decomposition in simple terms is basically when we talk about decomposition, you will study it in environment in significant detail about the, you have various stages of decomposition as well. So I will just list out those stages. I won't be explaining them as of now. So you have the various stages in which the organic matter is broken down. So this is the breaking down of the organic matter in the soil. Okay, the breakdown of the organic matter in the soil and return of nutrients to the soil. So you have various different stages of decomposition. You have fragmentation, you have leaching, you have catabolism, you have humification, and then you have mineralization. So all these are your various different stages of decomposition. At the end of it all, you will find no organic matter is left at the end of this entire process. Everything is returned, as the case of inorganic nutrients such as carbon, such as nitrogen. Everything is returned as inorganic nutrients. No organic matter is left behind. Okay. Now, here we talk about the classification of soil. So you have various different type of soils which are present. All of them is not important for your examination. For your examination, what is required to be understood is basically you have the prevalence or the 4 to 5 types, that is alluvial soil, then black soil, red and yellow soil, and then you have the presence of laterite soil. These are your various different types of soil which is available, which is important for your examination. Properties important for exam. So that is the case of the basic soil types that you need to be concentrating upon. Overall, just understand that in our case, the soil in across the country is generally going to be very poor in terms of nitrogen content. So urea as a fertilizer is substantially used. Ideally, urea, phosphate, and potash, that is what is also referred to as NPK. Okay, NPK. So that is nitrogen, phosphate, and potash. So those NPK need to be applied in the ratio of 4:2:1. That is the ratio in which you need to be applying the NPK fertilizers. But that is hardly the case. In many parts of India, for example, as we have already discussed, it is the availability, the easy availability when it happens. That is when the abuse of it starts. Anything which is easily available in general in your life, you will observe that the abuse process starts to happen. That is when we start taking things for granted, that it is always available, it is easily available. So when you have the very easy availability of urea, so people start applying them in large amounts. So for example, in the region of Punjab, you will come across a scenario where the application of NPK is in the ratio of 36:8:1. So here, ideal condition is what? That for 1 unit of potash, you need to apply 2 units of phosphate, you need to be applying 4 units of urea. But mostly you will observe in Punjab it is 36:8:1. So for 1 unit of potash, we are applying 36 units of urea. Right? Then you have another one, that is in the case of Haryana, it has been found to be 27.5:6:1. So that means for 1 unit of potash, we are applying 6 units of phosphate and 27.5 units of urea. Now that is the case of excessive application of fertilizer. Excessive application of fertilizer will immediately kill all the organic compounds, all the various different microbes, all the various different worms which are very important. Everything is immediately killed. And the soil starts becoming infertile. So this is one of the leading causes for the increased degradation of soil. And also understand, those of you belonging from the agricultural background or agricultural community, you would be aware of this fact that when you apply, let's suppose, X amount of fertilizer, that requires significant amount of water for that fertilizer to be digested of sorts, if you can use that analogy. So greater the amount of fertilizer that you utilize, greater amount of water also you have to apply for that fertilizer to be absorbed. So that also brings about the requirement of over irrigation. So all these twin factors are leading to degradation and eventual desertification of soil, particularly in the northwestern part of the country which has been witness to one of the most significantly increased amount of agricultural productivity in the past few decades. That is the region of Green Revolution. This is what has happened. Okay. Now, here, when we talk about the classification of soil and distribution of soil in various parts of the country, always associate it with the portion of the physiography. Always. Okay. So, for example, let's start with the portion of alluvial soil. So, alluvial soil, they will be created how? By the process of deposition. Always it is the process of deposition which will end up creating those alluvial soil, isn't it? So here you will have process of deposition, and this process of deposition means what? Carried by the rivers and the streams. Carried over by the various different rivers and streams out there. That is basically the requirement and that is the necessity here. So wherever you have the large rivers, smaller rivers, streams which are moving, they will be depositing certain materials on their side. Accordingly, we have studied that you have the case of newer alluvium, you also have the presence of older alluvium as well, isn't it? The presence of newer and older alluvium, both of them exist. So when you have the newer alluvium, that is more fertile. Older alluvium is less fertile, but nonetheless, it will be present in the floodplains created by the various rivers. Now, where do you find them? So you'll find them in the entirety of the region of northern plains of India, stretching from the area of Punjab, Haryana, all the way to the region of West Bengal, and furthermore in the region of Assam, where you have the Brahmaputra plains. All of them will form a part where you will have the predominance of alluvial soil. Then you have the small streams originating from the Aravalis. They will also end up depositing alluvial soil in the region, Rajasthan, Bagar as it is referred to. Then, furthermore, in the region of Gujarat, also you will have various different rivers and streams. So, in a narrow patch, there also you will have the presence of alluvial soil. So, alluvial soil is spread over. Then, the coastal plains that you have, coastal plains will also have deposits, eastern and the western coastal plain. So, Malabar coastline. Then, across the entirety of the eastern coastline, you have Mahanadi, Godavari, Krishna, Kaveri. All of them will form very fertile deltas. So there also you will have the presence of alluvial soil. So all of that is the area for the alluvial soil. So rather than learning the aerial spread, so people, they have a habit, candidates, they have a habit that they will read this and they will start learning each and every of this. Okay, Rajasthan, Gujarat, UP, Bihar, then in okay, I forgot Odisha. So Odisha, Rajasthan. So don't learn this process. Don't be like a kind of a parrot. Okay, what you can try to do is understand where that deposition will happen. Accordingly, there will be alluvial soil in that case. So Rajasthan and Gujarat, in certain parts, entire northern plains, eastern coastal plains, particularly the deltas of the various different rivers, these are abundant with alluvial soil. These alluvial soil, they are very, very fertile. Okay, they are found to be very fertile. So in the flood plains, wherever, and for example, whenever you have floods, recurrent floods, so recurrent floods, will they carry out greater amount of deposition, yes or not? What do you think? Yes, perfect. So recurrent floods will cause significant amount of deposition, so that will also end up depositing a lot of alluvial soil out there. So that is where you have the presence of alluvial soil, and this is fertile. Now here, will you be able to find some amount of organic matter or no organic matter at all? What do you think? Some amount of organic matter can be found or not to be found? It will be found, because it can happen that in the process of erosion and deposition, some amount of organic matter is also carried out in the process. So these are depositional soil. Okay, I did come across a very unique question. Flood is coming in Bihar every year, so why alluvial soil are not found in Bihar? If I can ask you the question, where is your source of information that Bihar doesn't have alluvial soil? Is that based upon a particular source, or is it something that you have come to a conclusion on your own? Because the entirety of the state of Bihar, other than the southwestern stretches where you have the Kaimur Hills and some part in the south central southern Bihar, which is surrounded by the northern portion of the Chota Nagpur Plateau, the entirety of the state of Bihar is constituted of nothing but alluvial soil. So that is why, again, I will ask you, where do you get these sources of information that Bihar doesn't have alluvial soil? If whichever source is there, all I am requesting you is, don't name the source. You have my mail ID. Please forward those sources of information. Okay, because that is a kind of an enlightenment. which which is there. So please don't get under this misconception. UP, Bihar, West Bengal, then the region of Punjab, Haryana, Assam, their entire economy, my dear friend, is dependent on the presence of alluvial soil. The entire population distribution in that area is impacted due to the presence of alluvial soil. Okay, so I hope now that is clear. Okay, yes, the entire concept of 4D that we studied. So here, when we talk about the alluvial soil, these are depositional soils that is created as a result of deposition. They are transported and deposited by the rivers and streams, that is the Himalayan rivers and streams. So according to the age, closer to the river channel, closer to the river stream, you will find the presence of newer alluvium, which gets deposited every time and every year, every week, for example. Further away and far away from the river channel, in the floodplains, you will find the presence of older alluvium, larger particles, isn't it? So that is where you have the Bangar and the Khadar. And we have seen that you have Khadar as the Khadar is what? Khadar is the newer alluvium, is more fertile. More fertile. Here you will have finer particles. Finer particles. The particle size is particularly small in this. When we talk about older alluvium, here you will find that larger particles. Coarse grained particles. Less fertile. And this is going to create or good for crops, or not good. It is the fine particle soil which is good for crops. There can sustain crops such as maize, pulses, etc. Okay, so that is the property of the alluvial soil. It represents almost 40% of the surface soil across the entirety of the country. Yes, even millets can be grown in this older alluvium, even millets, right? Millets also, oil seeds also. So they can be grown in these conditions of soil. So these are present almost in the region around 40% of the aerial coverage of the country. So observe here, the entire stretch, wherever deposition can be carried out and is carried out by the rivers, this entire stretch will be dominated by the presence of alluvial soil in itself. Okay, this entire stretch, and across the coastal plains as well, across the deltaic stretches as well. So these are amongst the most fertile soil types that you have. It is rich in potash, phosphate, as well as lime. It is very poor in nitrogen, and that is why you require urea to augment the fertility. They are ideal for the growth of sugarcane, paddy, wheat, and other cereals and the pulse crops. And due to the high fertility, regions of alluvial soil are intensively cultivated and hence are densely populated as well. Why? Because the fertility is so high, you will have a larger section of the population trying to indulge in agricultural activities. So you will have a lot of people settling in and around the same area. Small fragments of the land will be available for each one of them, and hence these are densely populated. So across the world as well, wherever you find the availability of alluvial soil deposits, there you will find an increased population as well, right? The density of population will be very high, be it the Nile Delta. Okay, Nile Delta in Africa also significantly populated. Okay, be it in the case of the eastern coastal part of China, many parts. So when you talk about China, the large population, a larger section of population is restricted across the eastern side. Western rocky areas are largely deserted. So that is because you have a substantial section of population living there around the deposits, because their agriculture as an economic activity is supported, and there you will have the population living there. Okay, now then we come over to black soil. So when we talk about black soil, they are also referred to as regur soil or the cotton soil, because they end up supporting the growth of the cotton crop. But this black soil is formed by the degradation or the weathering of the flood basalt, right? The basaltic lava that you have. So formed by weathering of flood basalt. Why is it referred to as flood basalt? That is because the basaltic lava, it spreads over, and it spreads in very thin in thin margins, and in very not very thick deposits, but in thin deposit it spreads over and moves over like a fluid over a larger area, hence the name flood basalt. Okay, now here they are also referred to as regur soil. Here you will find very fine particles, very fine particles. Now, will this soil have the presence of organic matter in this? Yes or no? Will this soil have the presence of organic matter? Okay. This soil is going to be poor in terms of organic content, and that is based upon the property of its formation, because it is formed from the basaltic lava rocks, the disintegration of basaltic lava rocks. Now these lava rocks or these igneous rocks, will they have the presence of organic matter? We have seen earlier that when we talk about igneous rocks, they are significantly poor in terms of organic matter content. Organic matter can be found in the sedimentary rocks, but not in other type of rock formation. Hence, these are poor in terms of organic matter content. Of organic matter. Okay. Now, when we say that they have the presence of fine particles, so that means ability to hold water and air, that will be also very high. So ability to retain moisture is very high. Okay, that ability to retain moisture is very, very high. It is ideal for growing cotton and is also referred to as the black cotton soil. So climatic conditions along with the parent rock material are the important factors for the formation of the black soil. Okay, now here you will observe it is something which is very typical of the Deccan Trap region spread over the northwest Deccan Plateau, which is made up of the lava flows. Even in the region of the Malwa Plateau lies slightly to the north of the Vindhyas. There also you will find the presence of this black soil. Okay, also found in the region of Malwa Plateau. In the region of Malwa Plateau. That is also where you will find the presence of this black soil. Okay, so regions, the plateaus of where is Malwa Plateau? North of Vindhyas. Did you locate the portions of physiography in the atlas as we had discussed? Located to the north of Vindhyas. Okay, good. See, there are certain students and candidates from whom it is expected, and trust me when I say this, over a period of time, we also get to know all the various different faculties. We also end up sharing a notes amongst each other about which student is very serious and where we find a kind of a prospect to gain a good rank, where we see the kind of a potential to gain a double digit rank or a single digit rank. So whenever I ask these kind of questions, that how many of you did that, it is not surprising that those names keep on getting repeated. Good. Carry on. So, for everyone, I would suggest that the portion in physiography that we have studied, try to locate it on the atlas, try to locate it on the physical map of the atlas. That will increase your level of understanding, that will increase your level of interrelatability with respect to the various different areas, for example soil, forest, and also economic and human perspective. Okay, now the regions of, or the regions where they are present, the black soil, that is the plateaus of Maharashtra, then Saurashtra, in the Malwa region, Madhya Pradesh and Chhattisgarh, and extended in the southeast direction across the Godavari and the Krishna valley. So some portions in the Uttar Kannada region, and some portion in the northern portion of Karnataka, some portion to the bordering areas of Telangana also, you will find the presence of the black soil. It is rich in calcium carbonate, magnesium, potash, and lime, poor in phosphate, nitrogen, and organic matter. Now, by the way, here, please don't entangle yourself with the task of learning these. That alluvial soil is rich in these, then the black soil is rich in this. UPSC had asked this question only once, and that too, it was about the laterite soil, and that worked on the process of elimination. UPSC is not going to ask you that whether potash is found in this soil or not to be found. If it asks you that, it will give you certain clues by which you can solve the answer. But please don't try to learn this up. Okay? Now, here, when we talk about the black soil, we have already talked about the fact that ability to retain moisture is very, very high. That means if let's suppose here we can, if let's suppose you have the availability of water droplet, now immediately all those fine particles, they will start clogging around it, they will stick around it. Okay, so they will start try to retain that moisture as much as possible. Now during the summer conditions, it plays out in a different way. While during the rainy season, that rainfall which is received, that is sufficient, and in black soil areas you don't require much amount of irrigation, because the rainfall received during the rainy season is sustained almost throughout the year, and that sustenance throughout the year is able to support the various different types of crops, right? Various different types of crops and crop cycles that you have. But when you talk about, let's suppose here, the summer season and the summer conditions, so what happens during the summer conditions? Let's understand that. So here, let's suppose you have the water droplets. Now, what will begin to happen is that immediately you will observe that the soil particles all around it, they will start to clump. They will start to clog around. Okay, they will start to clog around these droplets, trying to retain these droplets. That is going to be their purpose, nothing else. They will try to stick around these droplets. Now, what does it do on the surface though? On the surface, it will open up cracks. On the surface, it opens up cracks. Okay, so here this opens up cracks on, and that happens during the dry season where you have a limited availability of water droplets. That is where they will come together in certain patches. So that is where during the summer season it naturally opens up cracks, and cracks, when they appear, they will allow the percolation or the penetration of oxygen, air into the lower portion of the soil, increasing the organic content in certain cases, or otherwise increasing the air availability, because the roots also require the availability of air. So greater the amount of air which is held inside the soil, better it is for the plant productivity. So that is why we carry out the process of plowing or tilling. So plowing or tilling of soil, while it has got certain disadvantages, that you uproot the lower portion of the soil, so the soil moisture will be lost, but in general what you observe is that when you till or plow the soil, that is when the lower portion, or in general you allow the percolation of air to the lower region, which will be able to support the plant growth for a longer period of time. So this process of natural opening of cracks during the summer season, this is what is also referred to as the self-plowing characteristic of the soil. So here you will observe these cracks which are available. Okay, cracks which are available. So during the dry season, these soil, they develop wide cracks, which helps in the proper aeration of the soil, percolation of air in the lower regions. Thus, there occurs a kind of a self-plowing. Okay, now why does that happen? Because of slow absorption and loss of moisture, and because of this the soil is able to retain moisture for a very, very long period of time. It helps sustain the crops as well, particularly the cotton crop, which is planted after and during the monsoon season, that can sustain itself without much requirement of irrigation. So here you can also carry out a process of farming which is referred to as dry land farming. Dryland farming is a kind of an agriculture where you don't require the availability of irrigation methods, where you are dependent on the rainfall, and that rainfall will be sufficient. Okay, so dryland farming can be carried out. Okay, so that availability or ability of self-plowing is what, where it starts to develop large cracks. It opens up large cracks because wherever in summer season you have very limited amount of moisture, so moisture will be present in certain areas or in certain specks and particles itself. It will not have a uniform distribution. So all the soil particles will start sticking around those portions of moisture availability. And that is where you will observe that as it starts sticking up, then on the surface it will open up cracks. So that is the condition of self-plowing. Okay, allows in the proper aeration of the soil. Now, after that we come to the portion of the red and yellow soil. So red and yellow soil basically is to be found in those areas of the country where you have the presence of the igneous and metamorphic rocks infused with the crystalline iron particles. Okay, so red color is primarily imparted due to the iron particles. Even laterite soil for some in some areas have reddish characteristic or reddish coloration because of the presence of iron particles. That iron particle is not so high that you can start manufacturing steel out of it. Some presence of iron particles. So here, if both of them are formed by the same process, then why do we have a separate red soil and why do we have a separate yellow soil? So the basic formation is the same, but in areas which are drier, where the rainfall is not very high, there you will find the presence of red soil. In areas where you have sufficient availability of moisture and rainfall, in those areas, you will find that this particular soil, it interacts with the moisture and forms a hydroxide ion. And that formation of hydroxide ion imparts the yellowish color. So yellow soil will be found in those areas of the plateau where the rainfall availability is high. Red soil will be found in those areas of the plateau where the availability of rainfall is very less. So rainfall in high amount of rainfall causes hydration of the soil okay, turning it yellow. So it develops on crystalline igneous areas, rock areas of low rainfall in the eastern and the southern part of Deccan Plateau, and also the Piedmont zone of the Western Ghats, generally in the leeward side. That is, Piedmont means immediately along the region of the foothills on the leeward side, which is going to be dry. Now, if I ask you, will this be rich in organic matter or not? What do you think? Beautiful. It will be poor in organic matter, and that is because it has been created as a result of the degradation of the igneous rock. Igneous rocks themselves, they are poor in organic matter, so the soil type will also be poor in organic content. Okay, you told less amount of rainfall is red soil. Yes, that is true. Less amount of areas of low rainfall is where you have the red soil. And here the Piedmont zone that we are talking about, we are talking about the leeward side of Piedmont, refers to the foothills, regions of foothills along the leeward side. Regions of foothills in general, that is Piedmont. It is made up of two words, Pied and Mont. Mont here refers to generally mountain. So to the lower portion of it. Okay. Hydration means forms a hydroxide. Okay. So these are also to be found in the areas around the region of Bundelkhand, areas around Chhattisgarh, Jharkhand, Odisha, Karnataka. In all these areas, in Andhra Pradesh, also in certain areas, you will find them. So these are to be found in the entirety of the stretch of the Peninsular Plateau. I'll show you with the map as well. So here it develops a reddish color due to wide diffusion of iron in crystalline, igneous, and metamorphic rocks. Okay, igneous and metamorphic rocks. Yellow color happens when they appear in a hydrated form. In the occurrence of rainfall, you have the formation of a hydroxide. Then, the fine grained red and yellow soil are normally fertile, whereas coarse grained soil found in drier regions, they are poor in fertility. Coarse grain means larger particles. Why are they poor in fertility? Because of inability to hold in air and water amongst them. Water is not retained in coarse particles. In the case where the particles are larger, all that water immediately percolates. So it is poor in nitrogen, phosphorus, and even organic content. So observe this and here form an analysis of how to understand the various different soil types. So all the areas where you will observe deposition process to happen, there you have alluvial soil, right? Malwa Plateau and the Deccan Traps. That is where you will find the black soil. In rest of the areas of the plateau, you will find the presence of what? Red and yellow soil. Wherever rainfall is high, you will find the yellow soil. Wherever rainfall is low, you will find the presence of red soil. Okay, that is how you have the spread. So if a, a question comes in the mains examination about the types of soil across the country, please don't get worried by that. Please follow your exact logic. You don't need to learn the map. Draw the rough map. The portion across the north will have the presence of alluvial soil. Rajasthan Thar Desert is an arid, sandy soil condition. That is a different matter altogether, not to be found in other parts of the country. But then, when you come to the Peninsular Plateau, other than the region of the Deccan Traps and the Malwa Plateau, everywhere you will find red and yellow soil interspersed with areas of laterite soil. That is a different matter. But everywhere else, you'll find red and yellow soil. Okay. Now, then we have the laterite soil. Laterite soil is something that you would also have come across generally. It is found in patches almost everywhere across the country. It is found in those areas where you have a very distinct dry and wet season. Okay, very distinct dry and wet season, where during the wet season, very high amount of rainfall, dry conditions, absolute lack of rainfall. So in those areas, you'll find the laterite. Now, the word laterite is derived from the Latin word later, which means break. Now, this laterite soil is very, very hard, right? This, when it dries up, it becomes very significantly hardened. So it becomes very hard, right? Becomes very hard. But in Chhattisgarh, no volcano erupts. Okay. So that means a volcanic eruption happens in Jharkhand and Karnataka and Telangana. Can you tell me the last time that you heard in the news story that a volcanic eruption has happened in Jharkhand and and in the region of Karnataka? If your query is that in Chhattisgarh no volcanic eruption is happening, but why is it the red soil? See, that is why I told you to pay attention at the time of physiography. The portion is the aspect of it is that these are the individual, the formation of the Peninsular Plateau in itself has happened because of volcanic eruption. Okay, even Chhattisgarh, the region that you are so sure of that there is no volcanic eruption, it is true that for many millions of years there has not been a volcanic eruption. But the formation of all the rocks that you see around you, how did they get created? When you step outside your house and you look at all these large rocks, what do you think? How did they get created? Or have you never thought about it at all? So if never thought about it, it's a different matter altogether. But think about it. All of them have been created as a result of the volcanic eruption. Most of you would remember the portion of the Bastar Craton and the Chota Nagpur Craton, the Bundelkhand Craton that we discussed. Most of you would remember that. So how were those cratons created? As a result of volcanic eruption. Are we comfortable with that? Right? So are we comfortable with the spread of the red and yellow soil because of that? Okay, good. Now, then here, why it becomes very hard, why it becomes so, it is one of the most infertile soil out there. It develops under tropical and subtropical climate with alternate wet and dry season. There has to have an alternate wet and dry season in existence. That is the creation of the laterite soil. So here what actually happens is that, let's suppose this is the soil. Okay, now in the condition of excess amount of rainfall, very high amount of rainfall. Now the soil naturally will have certain minerals, certain nutrients out there. Okay. But in the case when the rainfall is very high, let's suppose these are your nutrients out there. Now, that water will start moving downward in direction. It will start dissolving the materials. It will start moving down. So all the materials will be dissolved by the water and it will be drained into the subsection. So all those materials which the water would have drained will accumulate in the layer underneath. So accumulation of nutrients. That does happen. So all that available nutrients gets accumulated in the lower soil horizon. So you will definitely observe the accumulation of nutrients. So the soil is drained out of nutrients. It moves down by a process which you refer to as leaching. This is the process which is referred to as leaching. Okay, the downward movement of nutrients along with water. Downward movement of nutrients along with water. That is something which is going to happen. So this laterite soil overall will be experienced in any area which experiences very high amount of rainfall followed by a very dry condition. If let's suppose there is availability of rainfall throughout the year, you will have a dense tropical evergreen vegetation. There the soil fertility again follows a very different dynamics that you confront and you study in the portion of environment ecology. But in general, you will find that when the soil is only dependent or a region is exposed to very heavy rainfall and followed by very dry condition, you will find the presence of laterite soil. So here it develops under the tropical and subtropical. Now this is largely used for brick making. Now this soil is considered to be infertile because all the nutrients have come to the lower level. However, with the help of proper soil conservation techniques, particularly in the region and stretches of Tamil Nadu, Karnataka, some parts of Andhra Pradesh, and also Kerala, there is an increased growth of crops. So, for example, in certain parts of Kerala, you have the laterite soil which is brought under conservation reclamation, and then it is used for growing crops such as the plantation crops such as tea and coffee. In the region around Tamil Nadu and Andhra Pradesh, there also it is used for tea and coffee, but also in Andhra Pradesh, it can be used for growth of crops such as tapioca. So if conservation methods are carried out, if proper conservation methods are carried out, this soil can be reclaimed, can be brought to productive utility as well. Okay, cashew also. Yes, Nikki, correct. Now, here basically you will observe that how all the above region of the soil is drained out of nutrients and all those nutrients have accumulated here. So when all the salts have been drained out, the soil will be acidic. Okay, so poor in nitrogen, phosphate, and calcium. After adopting appropriate soil conservation techniques, particularly in the hilly areas of Karnataka, Kerala, and Tamil Nadu, this soil is very useful for growing of tea and coffee. Okay. Now, then red laterite soil in Tamil Nadu, Andhra Pradesh, and Kerala are more suitable for crops such as cashew nuts. So, in regions where you find them, mostly in the region of southern states where you have heavy rainfall followed by a dry condition for a prolonged time. Western Ghats region in the portion of Maharashtra, Odisha, some parts of West Bengal, Even in areas around Aravalis in Delhi, you will find them. In certain areas of Bihar, you will find them. In certain stretches across Jharkhand, West Bengal, you will find them. So these are spread over in small patches almost everywhere. So they are widely used for brick in house construction for commercial purposes. Okay. Now, then we have the arid soil. Arid means you have the dry conditions. Arid. The soil is arid means it is very, very dry. So it is sandy in texture. Sandy, property of a sand almost, because eventually when the moisture is not prevalent and there's a consistent moisture deficiency, then all that moisture will be evaporated and you will be reduced with a kind of a sandy texture. So that is something which you find. It is going to be very saline in nature, right? Why? Because as evaporation will be significantly encouraged, and evaporation will happen at a very fast rate in these areas. Whenever evaporation happens, the salt gets left behind. So that is why arid soil in many areas are also utilized for the extraction of salt around the region of Rann of Kutch, for example. Okay, so here in some areas the salt content is very high, and common salt is obtained by evaporating the water. Due to the dry climate, high temperature, evaporation is faster and the soil lacks humus and moisture in general. Okay, the soil lacks humus. Why? Due to very high temperature, due to very high temperature, decomposition is almost absent. Not only very high temperature, but also complete lack of moisture. For decomposition, you need a moderate to high temperature along with availability of moisture. Here, you don't have any availability of moisture at all. So, due to high temperature, no moisture, no moisture, that is where you will observe that decomposition is almost absent and hence it lacks the organic content. Nitrogen is insufficient and phosphate is normal. Then you have the case of the mountain and the forest soil. So when we talk about the mountain soil, so just like as we move across the various different stretches of the mountain, the type of vegetation changes, isn't it? As you move from the lower stretch to the higher stretch of the mountain, the type of vegetation changes. Why? Because there's a change in climate. So they are also, because of the change in climatic conditions, because of change in the amount of weathering which will happen, the type of soil also ends up varying from the lower level to the higher level. Okay, the type of soil keeps on varying. So generally on the valley sides, you will observe loamy and silty soil, which is fine particle, very fine particle. So they are formed as a result of deposits themselves, right? So they are silty. Silty means derived from the term silt, which is brought by the river. So loamy means which can trap air in between them. So you have loamy and silty soil. These are fine particles. Fine particles are prevalent. Then in the upper slope, as you go higher up, the rate of degradation, the rate of weathering reduces. So that is where you find the coarse grained soil in existence. The larger grained soil in existence, that is what you find in the case of the upper slope. The snow-bound areas of the Himalayas, they also experience denudation or degradation. And here, obviously, the humus content in upper reaches will be very less because vegetation is almost absent. Organic matter, organic components are almost absent. That is why, in the case of the lower valleys, the soil are very fertile. Why? Because they are deposits. in nature. Okay. Then we have the saline soil. And Sayed, laterite soil, which you have mentioned as latient soil, is available where monsoon is intense and summers are also extreme. However, coastal areas like Maharashtra, they does not undergo extremities. So Maharashtra, not regularly in the coastal areas, but interspersed across the leeward side in certain stretches, and Vidarbha region. Vidarbha region is dominated by that. Certain stretches of the Sayadris, there also you will find that the summer is very, very dry. So there also you will find that. Okay. Denudation means weathering, erosion, those factors. Okay. Now, difference between humus and moisture. Humus is the organic component. Moisture is the availability of liquid water droplets. So then we have the presence of saline soil. Saline soil, which is also referred to as the Usar soil, because this is very infertile. Okay, this is heavily infertile. This is largely an outcome of high amount of over irrigation. You would have come across a practice in many of the places. You would have seen that people have this kind of an innate practice where they find that, okay, who will water the plants on a daily basis? Let me pour one bucket of water in the first day itself. It will be more than sufficient for the rest of the year, right? So you will find the people, they open up the tap water, and from the pipe the water keeps on draining into the ground, keeps on accumulating. Now, if ever you would have observed these areas, you can try this at your home as well. Any of the old flowering pots that you have, or in your backyard, anywhere. Now, there, some amount of water that you pour, that water will be absorbed. But if you keep on pouring it in the soil, and then you will find that there is a whitish kind of a pattern which develops on water. When water evaporates, it leaves behind those whitish pattern on the soil as well. What is that? That is basically your salts. Salts which have come from the lower portion of the soil by the result of the capillary action. So what happens here is that, let's suppose here, when you have soil, let's suppose you have excess amount of rainfall. Okay. Now these nutrients, it will dissolve. Let's suppose it is not the case of leaching. It is the case where these nutrients will be dissolved in water. Water will dissolve them, let's suppose. Okay. That's not calcium. Calcium is also there. Calcium is also a salt. By salt, please don't think only NaCl. Salt is any compound. Salt can be of any compound. So here, now after the rainfall has abated, or let's suppose the irrigation part you have closed down, now all that excess water will start to evaporate. All that excess water will start to evaporate. But when the evaporation happens, only the water droplets will evaporate. The salt particles now have been brought up and will get deposited on the top surface. So that whitish layer on the top surface will be created. That will become very, very hard. That is where the soil becomes substantially harder, isn't it? So it contains a large proportion of salts such as sodium, potassium, and magnesium, and thus are infertile. So they start depositing themselves. You'll find a whitish substrate appearing. They will deposit themselves on the surface, all these salts. And that is because of mostly dry climate and poor drainage. Okay. Poor drainage, if the drainage would have been good, all that amount of water would have basically been adjusted by the soil and the depth of the soil itself. But because the drainage is substantially poor, what that means, there is over accumulation of water. So wherever there is over irrigation, particularly in the tube well rich areas where you have high density of tube wells, where you have the practice where the farmers, you will observe many of them, because Electricity is also something which is available at a very subsidized rate in many of the areas. So what they will do is they will switch on the pump of the tube well. They will go to sleep. They will go switch it on late at night. They will go to sleep, and then around 4 a.m., 5 a.m., they will put that alarm. And then by that point of time, the entire field would have flooded. They would then close the tube well pump or motor. Now, what happens is as the sun begins to shine, all that nutrient, all that salt, it accumulates on the surface as the water is lost due to evaporation. Now, once that salt accumulates on the surface becomes so very hard, it does not allow the penetration of air and moisture anymore. So that makes the soil infertile. So that is where you will observe the soil becomes infertile. So it is found in arid and semi-arid regions and in waterlogged and swampy areas as well. So areas of intensive cultivation with excessive use of irrigation, in these areas you will find where you have excessive over irrigation which is carried out, particularly in the regions of green revolution where the fertile alluvial soils are becoming saline. So in these areas, what is being done is that, or what can be done as a solution is to increase and improve rather the texture of the soil. And when I say improve the texture of the soil, means improving the water retention and air retention capacity of the soil. If the soil is able to hold water for a longer period of time, all that water won't be evaporated immediately, bringing the salt to the surface itself. All that water will be retained by the soil. So that is why you add the gypsum powder into the soil. This is done to improve the texture of the soil, and by texture we mean will lead to better water retention capacity. Okay, so this can be done as a means of or as a method of solution. Do rice cultivation cause salinity? If you carry out the cultivation by flood irrigation, yes, it will cause salinity. We'll come to the portion of soil erosion, but before that, we take a break and then we carry on. Okay, gypsum, it will be the powdered form of gypsum. Powdered form of gypsum will increase it. So these will be fine particles, mix it with the soil. So gypsum naturally also absorbs moisture. So it will absorb all that moisture. Okay, right? No, there is no full form of gypsum. Gypsum is a mineral in itself. So we take a break, guys, and we will be back by around in 15 minutes. We'll be back. So that is when we'll be back, and we will carry on. Okay, Pula, it's the same pace that we are moving ahead with. I think you are finding it difficult to gather the portion of igneous metamorphic rocks and crystalline rocks in certain cases. So there I would ask you that have you revised the previous classes which have been held, or have you missed out few of the classes? So see, if you have been regular in the classes, you won't find much difficulty in these particular portions. But if you have missed a chunk of physiography, etc., then and even the basic rock formation, it will be very tough. Okay. Yes, Swati, we can consider. So let's take a break and we'll be back in around 15 minutes. Saturday morning from 6:30 a.m. we will have a session for geography where we shall be covering the final modules there. And as I told you, this time what we are doing is that we are having a separate doubt clearing session. A separate doubt clearing session where all the doubts that you have for the subject of geography, any kind of doubt that you have faced after reading the entirety of the subject, you can have doubts from various different areas, right? And that is absolutely acceptable. So any kind of doubts that you have, you should never have that feeling that my doubt has persisted after the live class has ended. So carry out the revision next Saturday. That is on the next weekend, not this Saturday, next Saturday at the same time in the evening session, we shall have a separate doubt clearing session. So, what you can do is that you can send all of your doubts into or to IAS Live so that we have a good compilation of doubts to be addressed. So, any kind of doubt for any topic of geography that you have encountered, why I have kept it on next Saturday is so that you will have around 7 days time to carry out the process of revision, to understand and analyze, and also to contextualize which portion of doubt is very prevalent and which requires to be solved immediately. So all of that you have to, you can bring it forward, send it to us to IAS Live, and we will answer all the kind of doubt. I will try to take in all those doubts, and then in that time duration from 5 to 8:30 next Saturday, that is 5 to 8:30 p.m. in the evening next Saturday, we will have the separate doubt clearing session. Is that clear? Okay, understood. Good. So I hope there is no doubt with this regards. Okay, from this another subject is going on, regardless when the other subject goes on, or when the other batch is started, we will have a separate doubt clearing session. There we won't be teaching anything new, there we won't be covering anything new in those doubt clearing sessions. We will only be covering those doubts, and that is why I encourage all of you, any and every kind of doubts, send it to us prior to those sessions at IAS Live so that your doubts can be compiled and we will take those doubts one by one. Okay. I will definitely help you with the aspect of how to revise geography. Saturday is going to be, we'll try to have the last session on this Saturday itself. We will try to have mapping on this Saturday itself. Okay. Right. And doubt has to be sent in email. Yes, send it to us at IAS Live. All the doubts that you have, send it to us to IAS Live and we will address those doubts. Okay. The extra class for this Saturday will be around 6:30 to 10:30, roughly around that time duration, 6:30 to 10:30. If the requirement is, we will extend it for maybe half an hour, or we can end it up before that as well, depending upon the completion of the module. Okay. Subject for email to recognize the doubt. You can write the subject that for the doubt session of geography, and you can put your doubt under that. Okay. No, not required to be given in doc file. Simple mail itself would also suffice. Fair enough? Yes, Mega, that will be more than sufficient. Roshan, the extra session, extra class will be from 6:30 a.m. The extra class for geography this Saturday will be from 6:30 a.m. Okay. Right. Good. So now we continue with the portion of the soil erosion. Now, soil erosion is what? It is the removal of the topmost layer of the soil. That is what is referred to as soil erosion. Okay. So that is what we refer to as soil erosion. So soil erosion is the denudation of the soil cover and subsequent washing down. Now, why is it that the top layer of soil will be removed? There are certain reasons why we experience this to happen. So, the reasons for the soil erosion is, let's suppose in a particular area, if you have plants and the presence of trees, now the trees will have their root systems as well. They will end up binding the soil. They won't allow the soil to move. But in any area where, let's suppose, you don't have the vegetation, so that means what? You will be left with a loose soil, right? So lack of vegetation creates loose soil. So presence of loose soil. Okay, loose soil, because that is something which will be eroded very easily. And then along with that, movement of water or wind with speed. Wherever you will observe the movement of water or wind with a kind of a high speed, now that will accumulate the top portion, or that will take the every loose soil particle which is available, which is free to move, and you will encounter a process of soil erosion. Okay, now in order to prevent soil erosion, what you need to do? So if you know the reason why that erosion is happening, automatically you will also be able to conclude that how to prevent that soil erosion. So how will you prevent soil erosion? By tackling these two reasons. That is presence of loose soil. So loose soil is present where? Wherever you have lack of vegetation, right? So in areas you can carry out the plantation processes, you can basically put in various different plants and crops. So there you don't have the topsoil which is exposed anymore. There you don't have the factor of the topsoil being able to be moved anymore. So the topsoil is bound and remained in an area. Okay, then movement of water or wind with a very high speed. So whenever you have the movement of water or wind with high speed, you can bring about certain breaks, certain kind of physical barriers or artificial bunds of sorts which you can construct that will prevent soil erosion. Okay, so here, when we talk about soil erosion, so this is the process of denudation or the removal of the soil cover and subsequent washing down. Washing down by the agent, or let's say rainfall, by river action, by wind action. Whenever they gain a sufficient amount of velocity, they will be able to carry it over. Now, in this, the top layer of the soil is removed and is carried away. Now, top layer of the soil is the most fertile layer of the soil. So, if the most fertile layer of the soil in itself is carried away, that brings about a general degradation in the quality of the soil, right? Because it is the top layer of the soil which allows the growth of the plants and vegetation. So if that top layer is removed, the bottom layer won't be able to support plant and vegetation and any kind of growth thereafter. So the process of soil formation and erosion, they carry on simultaneously. Generally there is a balance, but in case the erosion, the rate of erosion is very high, so in that case, when erosion rate of erosion is very high, in that case, what is observed? You will observe greater exposure of subsoil, and subsoil is going to be infertile. So it won't be able to would not be able to support vegetation. And that will lead to a kind of a desertification also in many of the cases. In general, it leads to degradation of the soil, leads to degradation of the soil, can lead to desertification. It can substantially lead to desertification. So that is the factor of soil erosion. Now, here let us take a look at the different ways in which that soil erosion is carried out, different types of soil erosion. So to tell you the very basic here, let's suppose in a region you have topsoil which is very loose, devoid of vegetation. Now, if ever you would have witnessed or observed it carefully, now there you will observe that when the droplets of rainwater they fall, they create a splash, isn't it? They will create a splash in this area. Now, some amount of that topsoil will be removed from that area as well, isn't it? So that is the very basic form of erosion carried out by rainfall. This is what is also referred to as a splash erosion. Splash erosion. Okay, where due to the occurrence of raindrops, you have the creation of a splash and you have the splash erosion. Then we have something which is referred to as a sheet erosion. Sheet erosion. Now, all these methods of erosion you will be able to observe only particularly in those areas where you don't have the presence of a lot of vegetation. If you have the presence of vegetation, it will bind the soil in its place. When you don't have the presence of vegetation, the soil is free to be moving from one region to another. So sheet erosion is what? Sheet means something which is very thin. So sometimes you would observe that if there is rainfall in a particular area, water tends to flow in certain small channels out there. So there they will start to remove the top layer of the soil. So observe here, the soil in this particular area has been moved out. The soil in this particular area has been eroded. Okay, so this is where the topsoil has been eroded. The topsoil has been removed. So that is what is referred to as the sheet erosion. So it takes place on a kind of a level land where the slope is not very high. So on a kind of level land, after a heavy shower, and the soil erosion and the soil removal is not even readily noticeable. So that is how thin layers of soil they get removed. So here very thin layers of topsoil is removed by rainfall. Okay, that is the sheet erosion. Now start applying your logic here. Now next time when there is rainfall in this area, water is more likely to flow from here, this place A, or water is more likely to follow this channel which has been created, that is B. If next time there is rainfall, what do you think? Where do you think the water will have its flow from? Good, from B, because already a kind of a depressed channel has been created in that area. So that is where the water will start flowing. So it continues. So When water starts to channelize its flow in that region itself, what will happen? That this particular area, it will start to get deeper and deeper. There will be a vertical erosion deepening which will happen. That creates temporary structures which are also referred to as rills. So deepening of these channels creates rills, and further deepening of them ends up creating gullies. Observe this. Observe how the water has simply carried away the soil in this region and it creates gullies. So this is what is referred to as gully erosion. Now, whenever you have gully erosion, so gully erosion, it does not mean that you have the presence of water here always. Generally, it is drier, right? But when rainfall will happen, water from all their surrounding areas will accumulate in these gullies and there will be a flow. So it will accentuate or accelerate the rate of erosion of these surrounding soil particles as well. So that is where these deep gullies they are created. And once you have these gullies created in a region, that region is not commercially utilizable because that region will be significantly crisscrossed with the presence of many different gullies in the same region. So there it won't be utilizable, the land won't be utilizable significantly. So that creates that kind of land or topography which is created, which is not utilizable commercially and from the point of view of agriculture. That is what is also referred to as bad land topography. Okay, bad land topography. So that is not utilizable significantly. So gully erosion is common where you have a steeper slopes, gullies deepen with rainfall, cut the agricultural lands into small fragments and make them unfit for cultivation. Now furthermore, even if let's suppose this process continues, then these gullies will become broader and much more deeper, and that will form ravines, what is also referred to as ravine erosion. It will end up creating and forming various different types of ravines in existence. Now, these particular ravines, they will carry out their process of erosion. And these particular ravines during the dry season, it will be the dry land. But when the rainfall will happen, temporarily there will be water flow. Again, it will be dry. So that is how you have these bad. So if ever you travel by train from the region of Delhi to Mumbai, Bangalore, Chennai, Trivandrum, anywhere, you will come across the portion in northern part of Madhya Pradesh, the region around, if you go around 20, 30 kilometers from Gwalior, you come across the region of Bamor and Morena districts. Now, these are very famous for the ravine and the gully erosion. There you will find a lot of this badland topography, and that is something you will be able to see even from the train tracks themselves. So that is where you will find a lot of. So generally in the areas where you have arid condition, because if moisture conditions and moist conditions are prevalent, so in those areas you will observe the presence of plants, vegetation will hold on to the soil. But in arid areas and drier areas, you won't have the vegetation, so that means loose soil. So in those areas you will observe a lot of that gully and ravine erosion happening. Okay. Yes, so Bamor, in the region of Bamor and Morena, you have this to be very common. Yes, in Bundelkhand and the entirety of Bundelkhand and Bagelkhand region as well. Yes. Okay. That gully leads to form valley. No, it will never get that deep that it will form a deep valley or something like that. No, it won't get that deep. Okay. So it is in the region of Morena, for example, it is the frequent sand mining which is carried out, which also leads to aridity and which also leads to the dry conditions. So suddenly when it rains, everything is drained away. And the sand mining mafias in those areas, they are so very prominent and they are so very powerful that if you belong from that area, you would be aware of the various incidents which have happened. So is there any use of gully erosion? Any kind of erosion is not good. any kind of erosion is not good. So don't think about it that this will be helpful or something like that. No, any kind of erosion is never good. Yes, the Chambal region is famous for the decoy tree. But also you had the around the time of 2012, 2011, 2013, you had the IPS officers who were also in a way targeted. The IPS officers who were targeting those sand mining mafias, they were in turn targeted. And you had the sad killing of a couple of them, where one of them was actually crushed underneath the heavy of these tractor trolleys. So it was a very sad case due to the sand mining mafias. So that is basically gully erosion. Yes, killed. Both splash erosion and sheet erosion caused by high rainfall. Yes. Okay. Now, then we have stream bank erosion. Stream bank erosion, if you observe, stream bank on the sides of the stream, right? On the banks of the stream. So here, it is the force of the river. And in areas where you don't have the presence of trees and vegetation, so the soil is loose, easily available to flow. So in areas, for example, let's suppose if the river moves like this, okay? So let's suppose here. Now the river will have a flow, the water will have a flow, isn't it? Now, if this portion of land, let's suppose, if this portion of land, if this is not having vegetation which will bind the soil, so the force of the river will carry it away along with it. So observe this. The banks of the river in itself, they are carried away. It is like they are being scooped away. So that is the stream bank. Now that stream bank erosion heavily observed in particular in the Himalayan stretches, where in the Himalayan rivers, where the rivers they suddenly increase in terms of their intensity and the water flow force during the rainy season. And that is where the impact is very significant. And all that water will eventually end up depositing itself. All that, rather, the eroded material, not water, all the eroded material will end up depositing itself in the river channel, reducing the availability of volume for the water to flow in the river channel. It can end up causing frequent floods as well. What is a bank? So when you have a river, if this is a river, this is what is referred to as a river bank. This is what is a river bank. The sides of the river. That is where the term embankment has come from. Okay, right? The river can get wider due to soil erosion as well, and also it can cause flooding. So, for example, in the region or in the rivers such as when you consider Ganda, Khagra, even Kosi, now they carry out a vicious amount of stream bank erosion. And in many of the cases, you have some settlements, the villages themselves, they in itself, they get cut off and they get carried away by the river water. When the flow is very high during the rainy season, the entire settlement sometimes gets cut off. Now, here, after this, we have the wind erosion. Wind erosion observed in the arid areas. Okay, so observed in the arid areas or arid regions. That is the very dry regions. Okay, and here basically, why only in arid areas? Because it is here that the wind velocity will be very high. Velocity is very high. A confirmation about the audio, guys? Audio is fine? Good. So the wind velocity is very high in the arid areas. Why? Because the force of friction experienced is less. Frictional force is very less. Okay. So if we artificially shift alluvial soil to badland topography, then does it work? As long as you don't fixate the soil in that region with the help of vegetation, it will again be carried away. So the only a kind of a solution to that is when you carry out afforestation, when you bring vegetation in that area, that will be a significant amount of solution and help. Stream bank erosion are found on the sides of the river, on the sides of the river where the river gains a significant amount of speed, and the banks of the river, they don't have either an embankment or the presence of the trees. That is where you will observe stream bank erosion. Okay. Now, it is most likely to occur when strong winds blow over light textured soil, that is fine particled soil, and that have been heavily grazed during the drought periods, leading to a lack of vegetation. Now, then we come to the process, or what is referred to as the soil degradation. So, what do we mean by soil degradation or degradation of soil? So, degradation of anything is what? Reduction in quality. That is what degradation is. So, it is the decline in soil fertility. Now, that decline in soil fertility can happen due to either ways. Because of mismanagement, let's suppose the decline has happened, or maybe the topsoil has been eroded and removed away. So, either due to erosion, or due to decline in fertility quality. Now, why is it that the decline or the nutritional status decline will happen? We have seen about the factors of erosion. So let us take a look at the other factors of soil degradation. Factors, I want your contribution one by one. And I want you to participate. Otherwise, if you are a simple mute spectator, then it won't help that much. So factors of soil degradation. First factor I will write is erosion. Okay. First factor I will write is soil erosion. Now start with the second factor. Overuse of fertilizer, good. Overuse of fertilizer. Then over irrigation, good. Over irrigation. Then lack of vegetation, that you can write in the factors of soil erosion. So there you can talk about lack of vegetation leading to soil erosion. So overgrazing, everything will be covered under this. Lack of vegetation. Then polluted water percolation in soil, good. Pollution. Land and soil pollution. Then not maintaining soil quality, climate change, unscientific agriculture methods, agriculture of same type of crop repeatedly, good. So growing the same crop over and over again. What this does, reduces the nutritional value of soil. Deforestation will be covered here. Deforestation and overgrazing, let me write here. Deforestation and overgrazing. Okay, after that, over mining, okay, shifting cultivation, urban sprawl and commercialization. But that will also come under urbanization, will also come under the portion of land and soil pollution that is caused due to urbanization itself. No break to recover the fertility, waste dumping in the soil, non-degradable material, salinization, organic matter decline, poor drainage of the soil, slash and burn activity, acid rain. Good. Or formation of acid rain. Okay. So then stubble burning, okay, and pesticides also, okay. So use of fertilizers, usage of chemicals, we will write. Okay. Natural disasters, not providing enough nutrients, yes. So these are the various macro causes. You can have sub causes in each one of them, but these are the macro causes which leads to soil degradation in general. When the soil degradation happens, generally you will find that the even the organic component of the soil that gets damaged, the amount of microbes, organic microbes that you have, for example the different types of worms etc that you have, their population reduces quite substantially. So that is what you find as the factor. So in as a result of this, you have organic microbes and worms get impacted and population or rather fertility reduces. Okay, so this is something which we are observing at a very large scale. In our country also we are observing it as at a very large scale, particularly in the regions which were supposed to be agriculturally self-sufficient and agriculturally like a paradise of production, that is Punjab, Haryana and Western UP, the green revolution areas. And in the areas of green revolution, due to consistent amount of over application of the fertilizers, the same crop, rice and wheat that has been grown there for decades now altogether, now the fertility has declined. Why? Because after a period of time, if you carry out the same process of cultivation without allowing the soil to recharge its nutrient, the soil fertility will reduce, its ability to produce more will reduce. Now what do people do? So people will apply more fertilizers. Now that will augment the fertility. Now that gives a wrong kind of a lesson. That last year I applied 4 kg of urea, I got 40 kg of wheat. This year I will apply 40 kg of urea, I will get 400 kg of wheat. But that is not how it works. So that is why in those areas you have had a declining agricultural productivity. And that is why since the 80s itself, various different agricultural scientists, they have always, professors, they have always argued that in the region of Punjab, Haryana, Western UP, if you don't go for diversification of crops, that is, you diversify it away from wheat and rice. Unless and until that happens, you will observe a reduction in fertility, you will observe a reduction in production, due to which there will be reduced farm income. And that reduced farm income creates a lot of scope for social unrest and social disturbance, which is happening. Now, this was predicted way back in 1984 by a very famous agricultural research paper, which was submitted by one of the doyens of agriculture. He was in Punjab University, Sardara Singh Johal. So, if you get an opportunity sometime, read his works. Now, obviously, I understand right now you don't have the scope to read the agricultural research papers. But there he suggested that in the 1980s itself, he said that, look, these regions, they have attained the maximum utilization of the land, so their income level will not grow any further by growing the same wheat rice, wheat rice, wheat rice. So rather than that, they should start growing vegetables and fruits, where the soil fertility can also be recharged, or they can diversify it to certain pulses as well to allow the recharge of the soil fertility, and then you can grow certain other crops. But then there you have the consistent cycle. That is why UPSC for past 10 years or so, in the portion of optional, sometimes in GS as well, has been asking the same question. And that is, what are the disadvantages of the continuous rice wheat cycle of crops? What are the, or why is it that crop diversification is required? How to get rid of the same cycle of crop growing in the region of Punjab and Haryana? So that is where it is leading to degradation of land. And degradation of land, mind you, that is not the end of it. Degradation of land is something which is leading to desertification. Okay. So when we talk about the desertification, so desertification is what? So desertification basically is, there are various meanings of it, associations of it. So one of the factor is the expansion of the existing desert areas. So let's suppose you have a region which is a desert. Let's suppose. Now this has got a lot of sand on it. Now let's suppose in a far off region closer to the boundary, let's suppose you have green crops and green areas. Now in the desert area, what do you think will be the wind velocity? It will be very high. It will carry the loose top sand, and that sand will end up getting deposited on top of this landmass. It will get deposited on this landmass, isn't it? So what do you have in that case? You will observe that this landmass then becomes infertile. The sand will not allow the growth of the plants, so the plants will also die eventually. So as a consequence, the desert area keeps on increasing over a period of time. So desertification is also referred to as the peripheral expansion of the existing desert. That is, the desert is expanding in all directions. That is also desertification. But the other factor of desertification, what do we call as a desert? A desert is where you don't have the soil having the ability to support plants, which is barren of sorts. That is what we call as desert, isn't it? So desertification can be due to expansion of the existing desert, of existing deserts. It can also be due to increase an area turning barren due to degradation of soil. So how is it that a barren reach or a degradation of soil can lead to desertification? So the process is very simple. When we talk about the degradation, soil degradation, for example, soil degradation. it will lead to reduced ability to support plants. Okay, reduced ability to support plants. When you have reduced ability to support plants, that means you will try to compensate it over application of fertilizers and over irrigation. Turns the soil saline and infertile. The soil saline and infertile. That means no natural vegetation. No natural vegetation in an area. That means you have the loose topsoil. Is exposed. That means now no natural vegetation, if it is there in an area, means region gets drier, very dry, and lacks rainfall. Okay, a region gets very dry if there is deforest or natural vegetation is not there, trees are not there, the rainfall pattern is always hampered, so the topsoil is exposed and it becomes dry also due to lack of moisture, so the topsoil is eroded. Topsoil is eroded. Subsoil gains a sandy texture due to very dry condition. And this is nothing but desert. Is this process understood, yes or no? Or is there any doubt which is prevalent in this topic? Understood? So let me tell you, this is one of those areas from where UPSC again repeats the questions multiple times. Okay, the questions in mains are oftentimes asked from this area, both in general studies as well as in the portion of optional. So you will have this question which is repeated: how degradation can lead to desertification? That was asked very recently as well. Okay, cold desert is a different factor altogether. Cold desert is not a creation or an outcome of land degradation. And Vivek, can we say Antarctica as, you can refer to Antarctica as a cold desert? Desertification is creation of a desert. That is desertification. That a normal land gets converted into a desert. That is desertification. Okay, normal land parcel of land gets converted into a desert. Now, this happens because of these two reasons. These are your reasons. Basu, how wind erosion will lead to it? So basically, if suppose you have an existing desert area, now it will have a lot of dry sand over it. Now that dry sand, let's say, is blown away by the wind, and is deposited in the periphery of that desert. So that dry sand, when it is deposited over the farmland or any area, will it allow the growth of the trees further or allow the growth of the plants further? No, it won't. It will serve as a hindrance. So that is where it leads to a kind of a expansion of the existing desert. So that is why you will study in the portion of environment and even in current affairs about the Green Wall initiative by Africa, where in order to stop the expansion of the Sahara Desert, they are planning the entire green belt to be planted to the south of Sahara Desert so that it doesn't expand any further. Okay, right? I hope that is clear. Yes, in the Sahel region. In desert area, all portions are sand or under sand portion soil exists. It is generally dried sand, and under that sand you have rocks. Okay. Is there expansion of Thar Desert occurring? Yes, it is in the portion of to the east and also in the portion to the north. Okay. Why Rajasthan is called desert area? As we know, agriculture are also found in that place. So is the entire so where are you getting these conclusions from that Bihar doesn't have alluvial soil, Rajasthan is the desert? So it is only the western portion of Rajasthan which is called a desert. Eastern portion of Rajasthan will have significant amount of vegetation. The southern portion of Rajasthan will also have vegetation. There you have the kind of trees, various different trees. If you come to the eastern, where you come across the Mukandra tiger reserves, the Ranthambore region, the Bharatpur region, these are important areas of bird conservation. These are areas where you have tiger. Can you find tiger in the desert? You won't. So please don't have this concept that entire Rajasthan is a desert. Okay, agriculture is carried out. Okay. Which type of questions can UPSC ask on this topic? I will give you the basic example. So from erosion, you can have the factors that in prelims that which of these can lead to soil erosion. And in the mains, you have the repetition of the question that how is it that soil degradation can lead to desertification? Okay. Right. Exactly. If you go to Rajasthan, first of all, do make it a point to visit Rajasthan. This is one of those areas which is not significantly explored by many people. But explore Rajasthan, the southern part of Rajasthan, even the western part of Rajasthan. It is not a complete. So the as I told you in earlier classes itself, the problem is that for many of us, the perception has of a desert has been created by the movies that we see, right? We see the movies where we see that endless expanse of desert where only those couple of actors and actresses will be dancing in the song, and we think that the entire state is like that itself. But Rajasthan, even in the western portion, after the occurrence or incoming of the Indira Gandhi Canal, significant portions have been brought under cultivation there as well. So, southern portion is in many areas you will have dense croplands. Look at the region of the Aravalis. In the region of Pushkar, if you go, it is one of the most beautiful areas that you will come across. Right. So it is not like that. And was Sahara Desert formed in this way? Sahara Desert is something which has been created in the recent past, around 10,000 to 14,000 years back. And that is because of the shifting of the landmass, shifting of the, and also as the landmass shifted in the subtropics. Initially, the monsoons, monsoon was a prominent phenomena. But then you had the subtropical high pressure belt in which that area lied. So that area started becoming a desert, and due to subsequent lack of moisture, the winds also started becoming dry. So it is a long process. And right now we come to the portion of soil conservation. So you were asking about the way forward. So soil conservation, how do you conserve soil? So when you talk about conservation of soil refers to the preservation of the quality of that particular soil. right? Preservation of the quality of soil. So quality degrades. Why? Quality degradation is observed due to either the process of erosion or the decline in fertility, the processes of degradation that we have studied. So if you have to conserve soil, you have to preserve erosion from happening, prevent erosion from happening. You also have to preserve the fertility. So how do you do so? So there, first of all, how do you prevent erosion from happening? So erosion happens due to lack of vegetation, and whenever you have the river and the winds gaining very high speed, that is when erosion will happen. So if we manage to put areas under vegetation, if we manage to put areas under forest cover, or if we bring a kind of a cover cropping. What is cover cropping? So let's suppose I have a farmland. I have harvested the crop, and then I have left the entire farmland barren just like that for the rest of the year. Obviously, the soil which is exposed will be eroded away. But if I randomly grow some crops here, okay, some vegetation, it will bind the soil in its place. So that can prevent erosion. Coverage of top layer of the soil, that will prevent erosion, that will prevent compaction of the soil as well, right? So that is one of the ways. The other is to reduce the flow of the water, the speed of the flow. So if you have a hilly terrain, there you will observe that the water flow is very high, the rate of flow of water is very high. So what you do is that basically you carry out, in these hills, you build terraces. You build terraces. Now what this does, it allows for the retention of water. Water is retained here. So water doesn't flow like this anymore. Rather, the water will have a kind of a stagnated, a stabilized flow. Okay, so a lot of that water will percolate. It will, when the water flow is stagnated, it won't have the factor of erosion, because we have seen earlier that carrying capacity is directly proportional to the speed. If the speed is high, it will be able to carry more. So reduce the speed, you will be able to reduce the carrying capacity automatically. So by terrace farming or contour terracing, you can, contour means what? A sinuous line like formation. So across these linear formations, observe the contours which have been created, right? So here, water will lay stagnant for some portion, some time. So there, crops such as paddy can be grown, rice cultivation can be carried out. Okay, so many areas in southern part of China. Now, the southern part of China is also mountainous with very steep hills and mountains. Now, in those areas, you had traditionally rice cultivation which would be carried out, but productivity was not very high because of frequent events of these erosion carried out, etc. Now, there you had a wide scale implementation of terrace farming, and that terrace farming significantly increased the total and overall productivity of that area. So the overall productivity suddenly increased. So soil conservation is a methodology to maintain soil fertility, prevent soil erosion and exhaustion, and improve the degraded conditions of the soil. Measures such as contour terracing, regulated forestry, controlled grazing, cover cropping, mixed farming, and crop rotation can be done to recharge the soil fertility. There is one thing, that is contour bunding as well. Contour here refers to the same, these contours that you see. But what do we mean by bunding? Bunding is the construction of artificial bunds. Construction of artificial bunds. And what are bunds? These are physical barriers. Physical barriers owing to, let's say, the kind of barrier that you can construct with the accumulation of sand, soil, etc. So what is done? So here, China sends pigs that they make a barren mountain in green. They placed green carpet all around the mountain. Yes, so that is also the case. But they are producing rice in many areas as well. Okay, so what is this? So basically, if you think about it, let's suppose you consider a slope like this. This is the side view. I'll give you the front view as well. Let's suppose the front view is something like this. Now, if there is rainfall, water will come down with an incredible amount of force. It will end up draining. It will come down with an incredible amount of force. It will carry a lot of soil particles. It will carry out significant amount of erosion. So what is done is, here across the mountain, you have these artificial bunds or physical barriers. How do those physical barriers appear to look like? They appear to look like a small accumulation of sorts. Right? All across this area, you construct a physical barrier. Okay? Then here. Now, sometimes what is also done is just before that, you also end up digging some ditches. You end up digging some ditches here. Now, what happens now is, if there is rainfall, if there is substantial amount of rainfall, now the water which starts coming and draining down, now rather than straight away rushing to the bottom, this water will start accumulating here in this entire ditch portion before it. It will accumulate. So water will stay here for some time. Wherever the water stays, some water will percolate lower as well. It will recharge the groundwater. Then, as the water flow continues to increase, slowly some water will start to flow over. But the velocity would have reduced by this time, because this is a kind of a stored water which is slightly overflowing rather than the rainwater rushing down the mountain. So here, this flows further. Again, it ends up accumulating here, right? That will again recharge the underground water level, and then the excess will then overflow. Okay, so that is basically where you are constructing the artificial barrier across the entire contour of that hilly area or the hilly stretch. So that is why it is referred to as contour bunding. Okay, that is why you carry out contour bunding. So these are the various processes that can be carried out. We'll take a look at another process, that is mulching. We'll take a look at it when we talk about organic farming. So mulching is another methodology which can prevent soil erosion. Mulching is simply covering of top layer of soil by factors such as, or by dried leaves, twigs, etc. That is what is referred to as mulching. Cover cropping is where you provide, or you rather than leaving your farmland barren, you basically plant any kind of crop which is out there. Okay, is that understood? This is artificial, obviously, artificial. Benefit of the ditch is that it stores the excess water and it reduces the flow of the water. Okay, now we come to the portion of agriculture. Is the sound okay, guys? It is not munching, it is mulching. Is the sound and the audio and the video, they are fine? Okay. Mulching, we will take a look at it at the end of agriculture. Is the audio and the video clear now? Is it better? Perfect. Works? Good. Okay. Now, here we come to the portion of agriculture. Agriculture is one of those areas which is relevant and which is becoming increasingly relevant for the examination. And that is because it is not a random choice which is made by UPSC. UPSC is asking questions from the portion of agriculture because farm income, crop failures, these are becoming prominent topics of discussion on a daily basis, because still, everything having said and done, we still have around 60 to 65% of our population in rural areas. We still have more than 50% of the population involved in agriculture. So their problems are something which are very pertinent and which are very important to be laid stress upon. That is why UPSC keeps on asking you questions from these areas. Now, in the portion of agriculture, what is going to be relevant for your prelims? Here, types of crops, conditions required, then you can also have basic features of organic farming, basics of organic farming. Then you can have methods of irrigation, and also this is just like other portions of Indian geography. This is also heavily dependent on current affairs. So any portion of current affairs that you encounter where a new technology for irrigation has come into place, where a new technology or a new kind of crop seed has come into existence, UPSC will definitely ask you a question from that. That is the reason that I advise you to study the portion of the magazine of Down to Earth, because Down to Earth is one of that magazine which will help you in environment ecology, which will help you in geography and the portion of current affairs as well. So that is the changing pattern. Okay, with the changing pattern, you cannot simply rely on the same method of preparation which was carried out 20 years ago. So the UPSC is, and the examination is focusing upon the recent trends and the changes as well. Now, agriculture, yes, agriculture is something that you will study in economy as well. Okay, where you will study about MSP, etc., all of those. But what I would advise you is that after coverage of this portion in geography, then coverage of the portion in economy, then take an overarching view of what is agriculture, what are the agricultural crises, why do they happen. That will give you a better perspective. Here we are going to cover it from the geographical perspective. Okay, and for the mains, what are the important areas? So that will be Mega. I joined the daily analysis of Hindu newspaper in YouTube at 10 a.m. So is it something which won't be available after 11? That Hindu analysis you will be able to avail that after 11 as well? I don't think there is much damn. See, if you want to attend the session, you will find the time to attend it. If you find excuses, so I'm not saying that you are trying to find excuses, but it is only one day aberration that I am trying to have, because on the 14th we had cancelled the class. The other alternative is that whatever portion is left, we leave it to the fate of God, that you will understand on your own. That is the other alternative. So you choose the alternative which is there. It is one day that I am asking for the extra session. Okay, there also you guys are negotiating that this year should be the time. How will I attend it? Guys, you are preparing for civil services. This is as serious an examination as it gets. Okay, so if you don't put in the hard yards, this is not your 10th board examination. Understand the magnitude of the examination that you are appearing. Majority of the candidates in the class, they won't even get through. Understand that and take that in writing. Majority of the people in any kind of class, they don't get through civil services. Only a handful will. So for that, you need to strive a bit harder. Okay, try to put in more amount of time, because 5 lakh 6 lakh candidates will appear. At the end of it, If you consider the merit list, 700 people will succeed. Now, do you think those 700 people, they are going happy go lucky every day on a daily basis? They are leading their lives just like any other, not giving too much care, and they will succeed in the examination? You do need to put in that extra effort. That for that we are providing you the guidance. For that you are here. For that we are here. So please don't have these kinds of silly things that, okay, basically Saturday I have this preoccupancy. In that case, you can take the case of the annotations of the PPT. Okay, you can take a look at the annotations of the PPT. That would also suffice in that case. So limitations, or rather, in the mains, you have questions associated with Green Revolution, and its limitations. Then organic farming, a type of organic farming, zero budget natural farming, okay. These are the basic areas. Now, here we will study about the different types of agricultural practices carried out across the globe, very briefly. Then we will cover about the cropping patterns in India, the cropping seasons in India, the different types of crops that you observe in our country. We will cover about Green Revolution, and we will also be talking about the portion of organic farming or zero budget natural farming. So here, when we talk about it, first of all, agriculture. So since your childhood days, whenever there would have been a requirement of writing an essay or an article about India, most of you would have started, or you would have been taught to start it with, India is an agrarian country. India is dependent on agriculture, which is true. Historically, we have been an agrarian nation, and we have been doing fine with ourselves, self-sufficiency. However, when the Britishers came in, the situation completely changed. You had the frequent occurrence of large scale famines. Famines, basically, where you have a shortage of food due to crop failure, due to dry conditions. Large scale famines, and people would die due to starvation. So you can imagine that during the British rule, you had crores of people who lost their lives due to starvation. A newly formed independent country was left to the mercy of nature. We did not have enough infrastructure to carry out the process of irrigation agriculture. Now, whatever infrastructure for irrigation, for water supply, significantly was built by the British, was built in certain sections of the country, and mostly in the portion of Punjab which went to Pakistan. So that is where a lot of canals were built. India, the newly formed nation, had a lot of issues, but the most important issue was the immediate lack of food. We did not have enough food to feed our population. We were dependent. We were dependent, just like our neighbors. We kept on looking to the Western powers that they will provide us with food grains. And at that point of time, United States, basically in their assembly, in their legislation, they passed law which was referred to as Public Law 480, what is also referred to as PL 480 program. It was that Public Law 480 program, or PL 480 program, was initiated by the US in order to provide food as a grant for free to the third world poor nations. And by this, they would supply food to Pakistan, India. It would make national headlines that another ship carrying wheat grains has landed on the Indian coastline. And that would bring cheers across the country that now food will be readily available. That would be the condition. Starvation would always be an imminent threat. But then We embraced methods of irrigation. We carried out agriculture. And agriculture is something that we owned upon. That this is not something that we will be completely dependent on the nature itself. We owned it up. From that day to the present day, the situation, if you analyze, as per the second revised estimates of 2022-23, India has managed to produce, as per the estimates, we have managed to produce close to around 323 million tons of food grain alone. For majority of the items, not only are we self-sufficient, self-sufficiency has been attained. For majority of the food items, either we are the largest or amongst the or the second largest, or definitely amongst the top 5 producers across the globe. From a country which would not have an independent foreign policy decision in certain cases because we were afraid that US will stop giving us wheat, we would be bound to follow many of their directions. From that stage to a stage that we are in now, where once India imposes a wheat ban export, the global wheat prices, they simply go out of the roof. When India imposes an onion ban or a high amount of tax on onion export, the onion prices, they spiral out of control. We are an important part of the agricultural production across the globe. And overall, the simple gross value addition provided by agriculture in our economy is close to, or is much more than around $200 billion, much more than our Western neighbors' economy, complete economy. Think about it. Our neighbors, that is Pakistan, is still in the same place. It still awaits the grant of the food grains in many of the cases. We, on the other hand, we don't have enough storage spaces for these food grains. Even this year, we have witnessed as per 2022 and 2023, we have witnessed a kind of a record harvest for wheat and rice. It is increasing. So that is where, yes, we have problems. We have issues in agriculture. Yes, often untimely rains due to global warming will lead to sudden escalation of prices of, let's say, tomatoes, onions, etc. And that is because we don't have the storage spaces. That those problems will come, but we have to appreciate from where we are coming from and how far we have come. So why do we study agriculture then if everything is going fine? That is in order to understand that how we can further improve. Because when we talk about agriculture, more than 50% of our population is involved directly or indirectly in this methodology of occupation or profession. And it contributes around 15 to 17% to our economy. So thereby, what does that mean? If more than 50% of your population is contributing only 15 to 17%, means what? There is inefficiency. There is a scope for much amount of improvement. How will that improvement come? If you understand why it is not suitable to grow rice in Punjab, Haryana, why is it more advisable to grow millets in many parts of the world? For understanding that, understanding what are the limitations of green revolution. Organic farming is good, but it has got its own limitations as well. That is why you study agriculture. That is why UPSC asks you question from this area. So with that, let us initiate the discussion. So basically, when we talk about agriculture, more than 50% of the population is involved directly or indirectly in the methodology of agriculture. Gross value addition is around $270 billion and more than that. Okay. Now here, when we talk about the exports from agricultural sector in itself is close to around $50 billion, right? India is expected to have produced around 316 million tons of food grains in 2021-22, and in 2022, 2023, as per the second revised estimate, it is expected to be 323 million tons. Okay. We will study technology in agricultural sector. No, that you will study in the portion of current affairs through various webinars, etc. The newer technology which comes into place. Okay. So that is the estimate in terms of production. When we talk about the methods of agriculture, the types of agriculture carried out across the world, you will come across primitive subsistence farming, intensive subsistence farming, commercial farming. Now, these are various names. As of now, it might not make much sense to many of you. So understand the basic meaning. Subsistence. What is the meaning of subsistence? It is basically that kind of a farming where you produce enough for your self-consumption. You don't produce to sell it in the market. You produce what you want to consume. That is the purpose of production. Some amount of surplus you save for sowing the crops next year. That is it. So what you grow, you eat, and then you save for next year. So that is for production, for self-consumption. Okay. Primitive means very rudimentary kind of tools and techniques which are used. Very rudimentary, basic, dependent on rainfall for the availability of water, dependent on natural fertility of the soil in itself. Okay. Dependent on the very basic forms out there, not having any newer technological methodology. Then intensive means what? Utilizing each and every parcel of the land. And thereby, let's suppose, as you would have seen in many of the households, particularly in the plain areas, you would have observed if it is a 5-member family, everybody helps in the farmland. All of them, they work directly or indirectly as agricultural laborers. So here, the farming is carried out purely in the mostly in the plain areas, purely dependent on fertile soil. Right. So here also technology does not play a major role. So there also, wherever you have very basic methods of agricultural methodology carried out, obviously the productivity will be less. The amount produced would be less. Whereas when we say commercial farming, this is cultivation purely for profit, to sell in the market, to earn good amount of profit. Okay. So very briefly, we'll take a look at these. So primitive, or should we take a look at it tomorrow? So we'll do one thing. We'll take a look at it tomorrow. We will carry it out, the primitive and the subsist shifting cultivation, etc. We'll take a look at it tomorrow, and then we will finish the portion of agriculture. We'll try to proceed into the area of minerals and industries tomorrow itself. Okay. Can we say commercial as both primitive and intensive? No, commercial is purely for profit purposes. Okay. And Lakshmi, today also I would give you the same portion for map pointing. Please point out, or please figure out the areas that we have studied in physiography of the country. In the atlas, just locate those areas. Will this module be helpful for IFOS? Which option are you talking about for IFOS, Vivek? Intensive, where you have the maximum utilization of the soil fertility of the land, you have the engagement of all the members of the family as laborers, you generate, grow food crops, not much profit generation for self-sustenance itself. Okay. Is desertification extending in the Gangetic Plains region? It is extending in the region around Haryana. To the southern part, so in the Shekhawati region of Rajasthan, and to the southern part of Haryana, and certain parts to the east as well. There any need to make hand notes of current affair? Rely on the revision of monthly magazines. If we artificially shift the alluvial soil to badland, that is what I told you earlier also, Shakshi. You need to carry out afforestation there. Okay, and digging a ditch won't increase erosion in slope. So that is something which will, we are talking about not a steep slope. We are talking about a gradual slope. So there, when you dig a ditch, it will allow the water to come there, stagnate for some time, and then slowly start percolating. Yes, if you don't have a question, you can leave the class. Okay. Can we have year where there is no El Nino or La Nina, or is it neutral? Or is it natural that there is always one phenomenon? No, you have normal conditions and neutral conditions as well. Thanks for the kind words, Laksh, but I'm sure many of you would be counting out the days, how many days for geography are left, and when do we get easier subjects after this? So it is a kind of a double-edged sword, my dear friends. So be careful what you ask for. Questions on soil section, we need to show location on map. If you have a detailed question about the distribution of soil, maybe then yes, otherwise no. And government restrict export of wheat and rice, so that is done in order to control the price rise. Geography is now clear, Gulam. So I hope the kind of trepidation and hesitancy that you were feeling in between, now that is gone. For Kosi prevention of flood, dredging is suitable. Other officers must be aware of it, sir, but why still there are changing of channels and flood still prevalent? That is because maintenance is not carried out, my dear friend. There are political reasons to it as well, right? So there is a no political governance in a way would be very much encouraged to invest billions of dollars for prevention of flood, because if the for that matter, if the politician goes to the village and says that now I have done something that the floods will not occur, and there is no meaningful change in the lives of the people won't vote them back immediately, would they? So they choose to invest money somewhere else, they choose to spend money somewhere else. That is why. uh, Good to know that, Shakshi. Anurag, I would suggest that have that approach for any subject that you cover rather than learning. I absolutely detest any kind of learning. So if you stop learning, if you start observing things, just think about one basic example. The storybooks that you would have read in your childhood days, you still recall them. But the textbook that you would have read 5 days back, you don't recall that. It is about how you read, how you learn. Change that, and this journey becomes very easy. Uh, Sarita, not now. As of now, get used to reading newspapers. June cultivation will talk tomorrow. If both splash erosion and seat erosion caused by high rainfall. So, splash erosion is the very initiation of the erosional process where the drops fall and the particles they are distributed. Okay, so that is where we will restrict here the discussion here today, guys. You have the webinars as well. Tomorrow we meet again, and then we'll meet again on Saturday as well. So that is where we'll try to restrict the session. And till we meet again tomorrow, do take care of yourself. Goodbye. Thank you, and have a good night.